Hey, class, and welcome back, all you cool polar bears and polar cubs. We're going to talk about conversion factors. Okay, so conversion factors are pretty much it's just a ratio. So, for example, like 1 dozen is equal to 12 of whatever that item is. Another one that is common for us is like 1 pair equals 2. These are all conversion factors. So we can go, hey, I got 3 pairs of shoes. And you can go, hey, you know what? That means I have 6 shoes. The thing that we use in order to do our conversion factors is something called dimensional analysis. Now, I get it. Dimensional analysis can sound a little scary, but once we get the hang of it, it'll go as smooth as butter. Okay. So what we're going to be doing is we're going to be switching units. Okay. The numbers initially aren't important. They're going to come next. So the first thing that we really want to do is switch units. So how do we set these problems up? Well, we're always going to have a given, and we're always going to put it over 1. So it'll be whatever you have as your given, put over 1. That's how you're going to start every single problem. It's going to be started out with that. Okay. The next one is our next factor. So we're going to set up another factor, and the unit from our given needs to come down. So we go diagonal in order to cancel out units. And you continue to do that until you have the unit that you wanted to be in. So for example, if you look down here at the bottom, okay, you'll notice that, we start out with our given over 1. That unit comes down. Now we have a new unit. That unit then comes down, and we have our final unit. Sometimes you can go directly to your final unit, and sometimes you have to have an intermediate step. So the big thing that we want you to get familiar with is the metric line. Okay, so here's the metric line. Okay, notice how we have this set and this set that move by 3s. The middle ones move by 1s. Okay, so you're going to go through and we're going to use this. Now, what this tells us, I'll change color. What this right here tells us is that you can take meters, liters, or grams down or up this metric line. So let's run through some problems. Okay, after you guys shot that down, let's run through some sample problems. So the first sample problem, we have 1 kilogram and we want to go to centigrams. So what we're going to set it up is we're going to put our given over 1. So 1 kilogram over 1. Now we want to get to centigrams and we want to get out of kilograms. So we set up another factor. On the bottom gets the kilograms because remember, we're going diagonal. And then on the top gets centigrams. Since it is only 1 step, we're okay. The majority of your worksheet, at least to begin with, is 1 steps. So now we have to ask a question. So the question is K or C bigger? Okay. Now, if you look at your metric line, K is kilo, that's 10 to the third. Centi is 10 to the negative second. So 10 to the third is bigger than 10 to the negative second. The bigger unit always gets a 1. So now up top, we put a 10, and we put the exponent is the number of steps we had to take on the line. So for example, from -2 to 3 is 1, 2, 3, 4, and 5. So this is going to become 10 to the 5th. Then all you have to do is just multiply the two factors together. And since the bottoms are all ones, this is going to give us 1 times 10 to the 5th centigrams. So if you were ever in a pinch and they asked you, hey, how many centigrams are in 1 kilogram? Well, it is 1 times 10 to the 5th. All right, let's move on to the next problem. So the next problem, I'm going to put the given in scientific notation over 1. So I'm going to move the decimal place over 1, 2, 3, 4 spots, giving me 2.1043 times 10 to the 4th over 1. And this is millimeters. On the bottom is going to be millimeters. And on the top is going to be gigameters. So you've all heard of gigabytes. That's the same prefix, giga, just attached to bytes in the form of data. So we go back, and we're going to look at our line. And from milli, which is 10 to the negative third, to giga, which is 10 to the positive ninth. So 1, 2, 3, 4, 5, 6. Now remember, these are 3 steps. 6, 9, 12. So this becomes 10 to the 12th when we have our factor. Well, giga is bigger, so that gets 1. 10 to the 12th goes on the bottom. Now our rules when dividing exponents is you take the top minus the bottom. So 4 minus 12 is going to give us -8, giving us a final answer of 2.1043 times 10 to the -8th gigameters. Hey, you just completed 2-dimensional analysis problems. You should be proud of yourself. So here's what I'm going to do. I'm going to give you a countdown. Okay, on this one. Again, I want you to try it and then unpause it and see how you did. Okay, then we'll go over this one and then we'll try the second one. So I'm going to count down from 5 and go ahead and pause it within that, and then go ahead and unpause to check your answer. All right, so we're going to count down, and it's going to be 5, 4, 3, 2, and 1. All right, so you're going to take 35 and put it as 3.5 times 10 to the 1st, and that would be milliliters over 1. In order to get to deciliters, deciliters is 10 to the -1st. Milliliters is 10 to the -3rd. So 1 goes with the deci since it is larger. And then here we're going from -1 to -3, which is 2 steps. So that becomes a 2. When you divide exponents, you subtract them. So you should get 3.5 times 10 to the -1st deciliters. All right, go ahead and check your work, and then we're going to get a countdown of 5 seconds to work on the next one, and then you can check your answer. 5, 4, 3, 2, and 1. So we're going to move this into scientific notation as well. 1.47 times 10 to the second. That's gigagrams over 1. We're going to nanograms, so we put that up top. Gigagrams goes on the bottom. Giga is bigger, so we're going to put a 1 there. Then you're going to grab your periodic table. And on the back is the metric line. Giga is 10 to the 9th, and nano is 10 to the negative 9th. So in between that is 18 steps. When you multiply exponents, you add, giving us a final answer of 1.47 times 10 to the 20th nanograms. All right, great work on that one. I'm going to count down from 5 again. And we'll go over the last one. So 5, 4, 3, 2, and 1. All right, so we have 0.86 terameters. So when you move that into scientific notation, you get 8.6 times 10 to the negative first terameters over 1. Now we're going to multiply it to get to picometers. And with that, picometers is 10 to the negative 12th. Tera is 10 to the positive 12th. So we're going to put a 1 on tera. And between 12 and negative 12, there are 24 steps. When you multiply again, you add. So you get 8.6 times 10 to the 23rd picometers. All right, those are our notes over 2.3. Go ahead and start working on that worksheet, all my polar bears and polar cubs.